Right, good afternoon and welcome to another ConeX supplier session. I'm going to do a round of intros in a minute. This one is all about reverse engineering, going beyond scan to CAD, which CHAB is going to be discussing, and the panel are going to ask questions. And anybody watching, please do comment on the LinkedIn side. Any questions, any thoughts, ideas as we go along as well. So, Ron, quick 20 seconds, introduce yourself.
Hello, everybody. My name is Ram. I'm the founder of Equitas Design Engineering and Innovations Limited. We are, as the name says, a design engineering services and innovation consultancy. We have offices in the UK and in India. That's it.
Superb. Neil?
Hello all, Neil Wharton, Sales Director at Render. We provide virtual reality, augmented reality and immersive software into engineering, and my background is CAD and PLM and engineering for sort of the last 15 years or so.
Fantastic. Clive?
Yeah, it's Clive Goodwin. I run a very small little agency down in Cornwall, in Falmouth, called Jam Sandwich, predominantly innovation, but on the product side, product design side.
Okay, I'll do myself as well, because then I'll hand over to CHAB. So myself, Adam Payne, I've got Factory IQ, which is a digital manufacturing SaaS software and a real-time machine monitoring system as well, Edge Essentials, but I also have other multiple small businesses as well. So, CHAB, over to you and kick off.
Yep. So, hi guys, my name's CHAB. I am the sales manager here at DOCAN. We are a design engineering consultancy and software distributor, and today's talk is going to be on reverse engineering, going beyond scan to CAD. Traditionally, it's something that that comes up quite a lot in our practice, so we thought we'd lead this talk on it. So I guess just starting off, kind of want to go on what is reverse engineering. So one of the most common definitions for reverse engineering can be described as the process of analyzing an existing product, constituent components to allow fully replicated design or design knowledge to be created from the information extracted, using these products and concepts as wide-ranging in structures and functions as mechanical devices, electrical components, computer software, chemical formulas, or even organic matter for all suitable analysis uses for reverse engineering. In practical terms, what this tends to mean is a reverse engineering project that will involve working backwards from a chosen product to determine the design and technology used by the product's creator. And then this normally leads to the formation of a digital twin, which can then be worked on for future conceptual development and refinement. Now, this is a very good summary of what reverse engineering is, but traditionally we've seen a lot of companies will leave it at just that. So you've got your digital twin. What comes next? Well, what are you doing with that digital twin? Because at DOCAN, we see this as a part of the puzzle, not the full solution. So there's so much more that you can do beyond this procedure. So the real value of reverse engineering is when you go beyond this gathered CAD data and start developing independent engineering processes, or start developing some further analysis to help you fabricate new necessary parts to extend the lifetime of machinery or equipment, or start developing new manufacturing processes that weren't available during the original product's lifetime. So before we get into the details of what this expanded process is, let's have a look at, I guess, why reverse engineering requirements can come up. So to be honest, this is one where I'd kind of like to open the floor out to the guys in the panel. I guess from your experiences, where have you seen examples of reverse engineering being required, if any?
Okay. I'll talk about a job that I did not that long ago. I was approached by a footwear company, and they wanted me to scan shoes, and then kind of colorize them, render them. And the whole point about this is that they didn't want to make all the different variants. They just wanted, they wanted to scan in 4 shoes, and from those 4 shoes, we could get over 100 different variants. But I must admit that the problem we were having was that it's all very well scanning something, but then when you want to cut it up into its component parts, so each part is so you can colorize each different part. That's where it became a bit more interesting, a bit more difficult. So it's all very well scanning one thing, but if you've got one thing which is made up of lots of different things, then how you cut those up and kind of get, you understand what I'm getting at.
No, absolutely. Like, I guess I mean, from our experience, the typical requirements for reverse engineering comes up in exactly those sort of cases where you've got an existing bit of tech kit that you want to use new methods on. Funnily enough, one of my favorite ones is files been lost. Some of these pieces of equipment, sometimes that come up for reverse engineering, are many years old, potentially even decades old. Digital files have been lost. Physical documents can be quite easily lost between transitions. Another example that we've had from quite a large site was where they were transferring data from actual physical drawings to digital, and they were done in a way that didn't necessarily retain the accuracy 15-20 years down the line. So now they have to go back and recapture all of this lost data across their large oil refinery. Another one that we've seen is one of the UK's largest refineries and sites, where they initially, this is going 15-20 years ago now, where they initially decided not to purchase the drawings for quite a large bit of manufacturing equipment, simply to reduce capex on the project and to keep schedules in time. And then that meant now that when the health and safety requirements have changed, and you have to go back and do further additions, you have to go back and do a lot of scanning and a lot of reverse engineering to have an idea exactly where you are in the first place. But so now we've kind of got this idea. I think we kind of want to develop more on what Clive is saying in terms of where do we go from that data. Well, what we do at DOCAN, traditionally we look at using that scan to CAD data, and then we want to go back and characterize the material, whether that be a shoe product or whether that be a large pressure vessel. You want to go back and characterize the material. Now, this involves typically taking what we like to call the lab to site process. So whether that's doing a bit of PMI on site, or whether that's simply having a conversation and doing a bit of testing yourself, you want to be able to understand what material it is that you're using. Once you've got that characterized, you can then develop that further in terms of defining the strength in situ. So if you've got the ability to bring it to a site, you can go off and define the strength of material, or you can go to the site directly and use methods like XRF to go off and define that strength as well. You want to get these parameters, so whether that's using ultrasonic to define the thickness, or looking at something beyond your initial scan data, you need that information to then go off and start doing your engineering simulations. And this is really where we get into the engineering simulation piece in this, because it's all well and good having that further expanded data. Now you need to get into the next stage of the process where you're using either hand calcs to establish working to set standards, or you're involving your CAE software. And this is traditionally where we can go further, and where you need to go further necessarily as well. So this can be done as part of the independent engineering process that will look to perform fitness for service potentially, or developing a engineering documentation, which is either going to confirm back the original calculations, the CAD drawings, material testing, and look to complete a full design review of the process. The sort of softwares that you can kind of use in this as well, very varied. So there is a whole lot of products suites out there. You can use everything from FE if needed, through to molding simulation processes as well that we'll go into. But essentially the idea is that you want to start creating documentation at this point in the process, and going from there. And then we really get into the value of the simulation piece. So although it's not always required in a reverse engineering process, simulation really can help in developing new methods that weren't possibly available at that time, but also identifying weaknesses as well. So this can involve everything from looking at the pressure vessels and pipe stress analysis using FE methods, or another example that might be quite relevant in this one, using molding simulation. So we've got a tool here called MoldX that essentially what it can do is can predict the flaws in the method of molding production. So this can allow for longer lifespan of rubber products, You can also simulate the creation of molds to allow for a first-time right approach, rather than having to go through multiple iterations of producing molds and going back again and again and again. So the idea is that at this point that we start really playing around with what parameters we've been given, and looking at it. So, you can complete full design review process from this, looking at instances where you've got the ability to go off and use new methods of formation. So previously, it might be a case of if we go back to that molding example, you were looking at forming molds by hand, and now we can use things like rapid prototyping to start developing our molds instead. So we've got a whole lot more elements to play with and make our manufacturing processes smarter, make our manufacturing processes a lot more lighter as well, not only in terms of manpower, but also in terms of costs as well.
Zihab, very
Yeah.
quickly on. I mean, again, I suppose this opens out to the panel as well. But what sort of like ROI side? You've mentioned the cost. So what sort of I don't like pinpointing this, but because it's dependent on the project and stuff like that.
Yeah.
What sort of things could you expect from it, from a benefit point of view, in doing this?
So absolutely fantastic question. So we've seen from guys who have developed, used, for example, molding simulations in terms of developing their molds. They've been able to take out 1 to 2 iterations of their testing process, and depending on what sort of product that is, that can be hundreds of £1,000s through to millions, depending on the complexity of the machined products, depending on what your specific testing procedure is as well. And developing your FE method in this manner as well can really help with that process. So it's all about having the right sort of approach depending on project. And it's not just molding simulations as well. You can look at fitness for service assessments as well. So we've had particular cases in this sort of example where we had to go and review a pressure vessel system that was part of a live oil refinery. We went and had a look at this through the reverse engineering method procedure, and we found, okay, well, with a fix, do you know what, we can actually continue to service this through the lifetime. So that can potentially save you in either a brand new pressure vessel cost, for example. It can save you on developing on time down in your factory as well. So if you don't have to replace a machine, you've got a fix that you can develop alongside your OEM training operational methods as well. So you've got a lot of scope for where you've got these savings to come from, whether that be from replacing the product or repairing the product.
I suppose some of that as well with reiteration. I think Steve Murphy's just asked here, do you have time saved sort of like in weeks, months? If you're taking iterations out of things, your lead time is reducing as well from a turnkey point of view as well on the process.
Absolutely. Obviously, the time savers categorized as to the amount of time that you're spending on the simulation as well. You need qualified people to be able to help you through that design process, to help you through that element. Naturally, not every single team has that in-house. That's where the likes of us and other companies come in. But where you have the ability there is, if you're not having to go back to square one each time a mold iteration doesn't work, or each time a rapid prototype doesn't work, you can cut that back by not only days, weeks, months at times, depending on the complexity of the project as a whole. But also in terms of material characterization as well. Once you've done that material characterization initially, you can then look as to, well, if we're making a replacement part, is there potential for us to use different sort of materials? Can we look towards potentially composites? Can we look towards smarter materials that are going to help us do the job better from the technology that we have now, not necessarily looking towards a technology that existed 10, 20 years ago? We're in such a rapidly developing climate. It's staggering, and I think we need to all just do all we can to keep up with it. I mean, to be honest, I'd love to hear any thoughts from the panel.
That's what I was just going to ask. Go on, Rob.
Yes, Rob.
Oh, sorry.
I see how good to see you again after that epic night in Bridgewater. Hello. So problem deconstruction is what we look at. One of the things of reverse engineering is what we look at as problem deconstruction, wherein it's similar in concept, but what we do is a bit different. Take a big problem that we're given, break it down into manageable chunks, and get to the root of each of those things, and then build the solution from the bottom up. Yeah, I know I'm talking at more of an ethereal level in terms of 60,000 feet above sea level, but doing this basic problem deconstruction, getting to the heart of the problem, helps you to build a better, more effective solution for the actual problem rather than solving for a downstream consequence. And that has a lot of similarities between what you've just spoken, Siab, because I'm an engineer who does things in the real world as well. And before we get to the real world, we'll need to look at all these things before we can get there. So I can see a lot of similarities between what you've literally spoken about and what we constantly do in our everyday life. So yeah, it's really fascinating, and it gives me more reassurance in the fact that what we're doing is kind of correct based on what you just told me. So thank you for that.
No,
Excellent.
I think that's the way as well, where it's very much a case of applying common sense to each stage. So you want to break down the project elements. We want to go down into the deconstruction element as well necessarily. So I think you mentioned that we did a lift of a 400-ton pressure vessel over a live oil refinery, and that meant a lot of breaking it down into chunks and thinking, okay, what do we need to, where can we save downtime? Where can we save? Where can we make this efficient? In the same way as well, when you have a smaller piece, whether it be, I think we recently did a laser scan of a small aerospace component where it had a few clear definitions, and we used a hexagon arm for that procedure. It was a case of identifying the right toolkits. Not every single time are you going to have to use a CAD works, or are you going to have to use a CloudWorks to go onto the site and do a massive scan element piece? You have to start from all elements of the procedure and think of what's the right tools that we need along the way. So whether that be doing a sub laser scan, whether that be doing getting the Boston Dynamics dog out, or whatever the case is, you want to make sure that you're characterizing the right tools along the process as well.
Superb. Neil, go on. You were going to ask a question as well.
You've kind of slightly answered that by mentioning a few, but I'll ask it anyway. Do you see it as industry specific? Are there any industries that it is more applicable or less applicable to? You mentioned aerospace then, and you mentioned molding prototypes, so I guess that's more automotive. So do you see it across industry, or are there any industries that it's more or less applicable to?
I think in terms of the brownfield world as well, there's a lot of demand for fitness for service now. UK is in an interesting position as we go through an energy transition, where we have to make a good use of our existing sites. So there's a lot of sites out there which have been built historically for manufacture that are now not being used as efficiently, and they need us to come in with modern methods. So particularly for oil and gas and manufacturing, there's a lot of scope. I think the scope for aerospace and automotive is different. What you're looking at for aerospace and automotive is a lot more around innovation rather than just maintenance. It's using the existing products that we have and then going off to develop new methods, new techniques that we can that make the process simpler, smarter. Whether that's trying to implement more AI in there, more machine learning, more visual elements as well. But whereas in the traditional industries for oil, it's a lot more around maintenance. It's looking at seal to prevent blowouts or to prevent collapses of structures. So it's a lot more varied as to the applications of it so far. But certainly, I think you can really start looking at different industries and saying, okay, well, there's different uses for it here, and there's different future uses for it as well. So each industry is kind of using it differently at the moment.
Makes sense.
So yeah, I'm just very quickly. I don't know whether Clive has got a question. I'm just picking up on what Steve Murphy has asked, and excuse me because I'm suffering from a bad cough. He said, "Can you model it now?" This is where I was thinking, picking up when you said AI. Mm-hmm. Can you model variation? into it, and is this where AI actually comes into play with certain things as on this as well?
Yeah, so this would happen more so if you're going towards the innovation side, or if you're going towards a full independent engineering process, rather than just going off and justifying what's already there. But yes, so there's tools out there now, such as by MSC, Odyssey by CAD. That's more for CFD, but you've also got Smart UQ as well. So these are tools essentially where you can set defined parameters. You'd run a test of the model at a certain parameter. You run a test at another parameter, and then the AI essentially does a lot of machine learning between those 2 points and goes off and runs hundreds and hundreds of tests on its own system, and it will come back to you with what it thinks is the best element, what it thinks are the best parameters for you to go with, to create your the design element that you're going for, whether you're looking at fluid structure interaction, whether you're looking at a part for an aeroplane. You can go off and certainly do that, and then you just have to run the test to verify it at the end. You've also got some fantastic tools in Apex generative design, where it will use the AI as a background tool to the human to help you with saying, okay, well, this element can potentially be thinner. This element can potentially, can work in a different way as well. So you've got a lot more tools there. You certainly need the expertise to guide them. They're not there yet where you press a button and it automatically runs. You still need the technical expertise to set up those models. And you've certainly got the ability now with these tools to look at both FEA, CFD, for in a whole other light.
Clive, was there anything you want to add? I wasn't sure.
No, basically, I mean, that's what we used it for. We'd scanned these shoes, then spent maybe a week or so cutting the scans up, and then using those scans to remodel shoes and changing those to get the variants. So from 4 shoes, you can get as many as you like.
Somebody who did previously ask, and it was Andrew Thomas, did previously ask, saying, once you've reversed engineered something, can you secure a design as an NFT?
I don't know nearly enough about NFTs, but I'm sure if you've got the ability to secure IP in that way, then go for it.
Right.
It's I think this is getting a bit beyond my knowledge.
Okay, brilliant. I don't know whether we interrupted you in what you were delivering in your speech. So
No, to be honest, I think we're kind of coming towards the end of it. I think really what I'd want to talk about next is just the sort of tools. I think is everything from the interest. It seems that people are interested in sort of what tools you might use to develop these sort of projects. So from a scanning perspective, obviously you've got a variety of different tools available to you, whether that be hexagon arms or the different Leica geosystem scanners, any of those sort of, depending on the size. But what do you actually do with in terms of the that scan data? Well, we've got a variety of different CAD elements to help us, whether that be hexagon recreate, which essentially uses to streamline the reverse engineering process, or 3D systems, Geomagic DesignX. DesignX is traditionally one of the most common ones in the industry at the moment. What's really good for is manipulating large point cloud data files with a lot of interoperability. So whether you're working with scan data, you can use that to mesh repair tool and deliver rapid hole fillings and so on, as well as looking at polishing, different forms of scanning data as well. You really get accurate geometry with that. And then when you get onto FE methods, yeah, there's a whole variety out there. In terms of whether you're looking at different FE models, CFD packages. Every company is going to have their own. But as a design consultancy, we favor MSC 1 quite a lot. It's just the most flexible one for us. It gives us access to FE, CFD, multi-body dynamics, all of that. and in a really reasonable way. Also some really credible products such as Mark in there as well. But then when you're looking at more specific sections, you've got also PV Elite as a software you can use for pressure vessels. Tank is another one you can use to look at specifications depending on what you're working towards as well. But really, you need to have a good CAD system to start off with. We'd recommend BricsCAD. Naturally, it's a very good CAD system. If you're already using AutoCAD or anything like that, you can probably switch across to it as well. But essentially, there's a whole variety of suites out there. It's very much a case of finding what works for you, and finding a partner who's going to help you through this process, because there's a lot of pitfalls in this, and it's very much a case of you need someone who's going to help you achieve what you want, like Clive did with that shoe company. It's not necessarily something that you can go off and do yourself. You need a strong partner alongside yourself to walk you through.
Okay, brilliant. Before we finish up, is there anything else from the panel? Anything to add? For anybody wants to add, ask. No, we're okay. Right, Zihab, go on, sorry, Rob.
Just a comment. I mean, I just wanted to say thanks, Zihab, that it's been an insightful and eye-opening session. Thank you, Zihab, for taking the time. That's all.
No,
Superb.
pleasure.
So what I was going to say, Zihab, where can we find you? Obviously, LinkedIn, because we're all on in LinkedIn. But where else? Website?
Yep, so check us out on DOCANco.com. There's a whole lot of information about everything I've mentioned there. We've got a load of brochures there as well about this sort of stuff. But otherwise, drop me a message on LinkedIn, and yeah. But all I'll do is sign off by saying, have a very Merry Christmas, everyone, and a Happy New Year.
Yeah, thank you very much to the panel as well. This is on behalf of the ConeX portal and the relaunch and upgrade of ConeX portal. You can find that www.conex-portal.co.uk. We haven't got Sam here or Angela here. I, for one, part of it. I know Ram has been involved with it, and the rest of us. Great organisation for progression and collaborative working across manufacturing, engineering, and all manner of different service sectors. So do look it up, because it is worthwhile looking into this, because it's very much collaboration in moving forward. So yes, thank you very much for your time. Thank you very much for the comments and watching in. And as Siab said, have a great Christmas and New Year. Thank you very much.
Bye.